In this video, I am going to discuss about different types of angles, their components and units. To draw an angle, we need only two rays. Let's draw an angle using the ray AB and CD. To draw an angle, we have to first place the two rays at the same position and to join them at their fixed ends. So the two rays are joined at their fixed ends, but they are free at their arrowheads. Now simply turning the arrowhead of one of the ray, we can draw an angle. So an angle is made at the fixed ends of the two rays. An angle has three components: the initial arm, which remains fixed at its position, the terminal arm, which keeps on rotating, and the vertex or origin along which the terminal arms rotate. We can make bigger angles simply by turning the terminal arm to any direction, either clockwise or anti-clockwise. An angle is represented by the symbol theta. Theta has two parts. One is value and the other one is unit. The value says the magnitude of the angle or the side of the angle, and the unit says the scale in which the angle is measured. The unit may be expressed either in degree or in radian. Let's draw angles of different magnitude using these two rays. So we have to place the two rays at one position. I'd like to place the green ray above the yellow ray and then joining the two rays at their fixed ends. Now the two rays are free at their arrowheads. The arrowheads can be turned to any direction, either clockwise or anti-clockwise. I would like to turn the arrowhead of the green ray to the anti-clockwise direction. An angle is made along the vertex. The angle which is made here is of 45 degree. The angle which is less than 90 degree is called an acute angle. Now rotate the terminal arm and make it stand vertically straight upon the initial arm. The angle that is made is marked as a square because it is a right angle, that is of 90 degree. As we rotate the terminal arm a little more, it will make an angle that is more than 90 degree. The angles which are more than 90 degree is called obtuse angle. Now rotate the terminal arm straight to the opposite of the initial arm. The angle that is made, that is of 180 degree. The angles which are of 180 degree are called straight angles. On further rotation, the terminal arm moves to the downward direction, and when it stands straight, keeping the upside vertically down, it forms a reflex angle that is of 270 degree. The angles which are more than 180 degree are called reflex angles. But when the terminal arm comes up on the initial arm to the same direction, it completes one full revolution and makes a complete angle of 360 degree. But we can still rotate the terminal arm more and can make bigger and bigger angles, such as 389 degrees. And if we keep on rotating the terminal arm more and more, the bigger and bigger angles will be created. And when the terminal arm completes two full revolution and again comes up on the initial arm to the same direction, it creates a double complete angle of 720 degree. Still we can rotate the terminal arm more for a bigger angle. So we understand that there is no maximum limit of an angle, or theta may tend to infinitive, but theta has signs. What does it mean? It means that when the terminal arm rotates to the anti-clockwise direction, then the angle that is made, it is called a positive angle. Then the theta is considered positive. But when the terminal arm rotates to the clockwise direction, then the angle it is made is considered negative. Then theta is negative. The angle in between these two rays is 1 degree, but we can draw angle smaller than 1 degree. But at first, we have to understand 1 degree angle better. When terminal arm stands as a perpendicular on the initial arm, it makes a 90 degree angle. If we divide a 90 degree angle in equal 90 parts, then one small part will be 1 degree angle. So we can say that 1 degree angle is the 1/90th part of a right angle triangle. To draw an angle which is smaller than 1 degree, let's zoom in the 1 degree angle. So it is our 1 degree angle. Now divide the 1 degree angle in equal 60 parts. Then one small part of the angle will be of 1 minute. So 1 minute is the 1/60th part of 1 degree angle. Still we can draw an angle which is smaller than 1 minute. When 1 minute angle will be divided in equal 60 parts, then one part of the angle is 1 second. So 1 second angle is the 1/60th part of a 1 minute angle. Still we can draw more tiny angle. So we can understand that theta has no minimum limit and theta has no maximum limit. Radian, the SI unit of angles. Let's discuss about the SI unit of angle radian. This is our x-axis and this is our y-axis. In this xy plane, I would like to draw a ray OA. The ray OA can freely rotate in this xy plane along its axis at the center O. Taking the ray as a radius, I would like to draw a circle. The circle touches the circumference at the point M and it cuts an arc on the circumference from the x-axis. The arc has an initial point N and the terminal point M, and the arc subtend an angle at the center. We can measure the magnitude of the angle that the arc subtend at the center on dividing the arc length by the radius of the circle. The yellow ray is the radius of the circle. Let the length of the radius is r. So when we divide the arc length by the radius of the circle, then we get the magnitude of the angle that the arc subtend at the center in radian. Radian, symbolically, it is expressed as a small c in superscript form. To understand radian, let's draw an angle of unit radian. But how? Let's assume the radius of this circle is 1 centimeter and this red line segment is also 1 centimeter, same as the radius. Now I'd like to adjust the line segment as an arc on the circumference. So this arc is of 1 centimeter and the arc subtend an angle at the center. To calculate the magnitude of the angle, we have to divide the arc length 1 centimeter by the radius 1 centimeter. Then we get the magnitude of the angle that the 1 centimeter arc subtend at the center, that is 1 radian. Now what is radian clear to us. Still there is some confusion about the value of radian. The value of radian can easily be understood by the perimeter formula. The perimeter or circumference formula is 2 pi r. The circumference subtend a complete angle at the center. On dividing the 2 pi r by r, we get the magnitude of the complete angle, that is 2 pi radian. And in degree scale we know that a complete angle is of 360 degree. So we can say that 2 pi radian equals 360 degree. Using this formula we can calculate the value of 1 radian. We know that pi is 22 by 7 or the value of pi is 3.1428. we have to substitute this value in the formula. So on dividing the 360 degree by 2 into 3.1428, we get the value of 1 radian, that is 57.27 degree. So 1 radian equals 57.27 degree. So this unit radian subtend an angle of 57.27 degree at the center. Then let's see how many radians makes a complete angle. This is the first radian. This is second, third, fourth, fifth and sixth. But only this small part of the circumference is left to be covered. And we know that semicircle subtend an angle by radian and the complete circle subtend 2 by radian, and 2 by radian equals 6.2831. So 6 and 0.2831 radians makes the complete angle.